Okay, so we'll go over some questions from page 460. Just so you guys know what our agenda is for today. Today is going to be like a catch-up day. So I'm not introducing anything new. I'm not assigning anything new today. Since I haven't seen you guys in a couple of classes, I wanted to give you some time to ask questions. For those who might be struggling a little bit with the trig stuff, with the law of science stuff, you'll get a chance to ask me some questions. We can go over some of those today if you like. The homework assignments, the 2 law of science homework assignments, if you have them today, I'll check them off today, but I'll still give you full credit for them on Tuesday when I see you again. Okay. So let's start with 29 here. So I'm going to let you guys kind of lead the charge here. I'm seeing a couple things when I look at this. The first thing that comes to my mind is Pythagorean identities. Let me grab my sheet here. I see lots of squared stuff, and that always makes me think of Pythagorean stuff. I also noticed that like we got cosine and cotangent on both sides. This is kind of weird. You can subtract these 2 things, and it's the same thing as multiplying the 2 things. How do we turn subtraction into multiplication? That's a great question. There's a couple strategies. One of the big strategies is if they were fractions, turning subtraction into multiplication often happens by getting a common denominator. So I could make cotangent into a fraction, and I could make this into cosine squared over 1. And maybe I could try get a common denominator. That could work out for us. The other way, if we started on this side and we were trying to turn something into subtraction, a lot of our identities can turn into subtraction. For example, cosecant squared minus 1 is equal to cotangent squared. So that could be a potential strategy as well. So when I'm looking at this, I'm just kind of thinking through what I could try. Ultimately, though, I need to decide whether I'm going to start working on the left-hand side or the right-hand side. Does anybody have a preference? What do you think? Left? And that would be what I would generally choose as well, because subtraction is usually more difficult to deal with than multiplication. So we'll go ahead and start here. And I'm tempted to start using, I would be really tempted to start using trig identities, like maybe turn cosine squared into 1 minus sine squared. However, I want to eventually get back. I don't want to change these, right? We're going to need them. So I think that changing this into 1 minus sine squared would kind of be moving away from our ultimate goal here. So I think I'm going to try the thing where we write things out all in sines and cosines, and this is going to turn into a fraction. Then I can combine these together with a common denominator. So that's going to be my first strategy. So cotangent squared is cosine squared over sine squared. And then minus, I'll leave some space here for my magical 1 I'm about to multiply that by. And then I've got cosine squared x over 1. So trying to get a common denominator. So this one has a sine squared x, thank you. This has a sine squared x in it. This has a 1 in it. I guess we can just leave that alone. This one needs a sine squared x in it, so I'm going to multiply by a version of 1 that's got sine squared over sine squared. So now everything should come together into one big old fraction that's just got sine squared x in the bottom. I don't know if this is going to work or not. And then this would be minus. Then I got cosine squared x, sine squared x. Ooh, I like it. Did y'all hear that? We had a suggestion to factor a cosine. We've got 2 terms in the numerator up here. They both have cosine squared in it. Should we try that? So if I factor out a cosine squared x, then what will we have left over in there? 1 minus sine squared. 1 minus sine squared is cosine squared. 1 minus sine squared is cosine squared, isn't it? Because if I start with this identity and think about subtracting sine squared from both sides, we'd end up with 1 minus sine squared equals cosine squared. Yeah. So I got cosine squared x and then another cosine squared x and a sine squared x on the bottom. What are we trying to get to again? We need cosine and cotangent. Oh, I see the cotangent. Cosine over sine, right? Cosine squared over sine squared is cotangent. So if I split this into two fractions, cosine squared x over 1 times cosine squared x over sine squared x. And then our next step would be the last one. So that worked out. So remember those strategies. One of them was, if you get totally stuck, try turning everything into sines and cosines. So we did that here. And then I remembered that oftentimes, if you have fractions with different denominators, it's a good idea to combine them together into a single fraction, get a common denominator and combine them. Cool. By the way, I think this is even faster if you start from this side. I think we were talking about this yesterday. Is it? How would that work? Maybe not. Never mind. Let's not bother with that. What else can we got a solution. Let's just be happy with that. No, I think you can from this. And I think what you end up doing is, yeah, so you change cosine squared into 1 minus sine squared. That's it right there. You change cosine squared into 1 minus sine squared, and then you distribute. So this would be cotangent squared x minus cotangent squared x sine squared x. And then when you change cotangent into cosine over sine, the sines are going to cancel and you're going to get cotangent squared minus cosine squared. It's actually a little bit faster to do it that way. All right, what else do you guys want to talk about? Which one? 28? 28. Ooh, that looks fun. Cotangent v minus 1, cotangent v plus 1 equals 1 minus tangent v, 1 plus tangent v. That's interesting. So I look at this and I start thinking about, remember how we talked about how that a plus b times a minus b gets you a squared minus b squared, and how we can sometimes use that to make these Pythagorean identities. So that's the first thing that popped into my mind, except if I'm going to do that with cotangents, I'm going to end up turning them into cosecants. And I want them to turn them into tangents. So I'm kind of thinking maybe that's not the right strategy. Maybe I could work on this side, but then I'd be taking tangents and turning them into secants. And I got a feeling that that's might end up working out, but there might be an easier way to do it. So then I'm thinking, gosh, she's looking off. The format of these are really similar, right? They're both in fractions. They both have a minus on the top and a plus on the bottom. What's the relationship between cotangent and tangent? They're reciprocal functions. what happens when you multiply two reciprocals together? You get 1. I think that's probably going to be the key. You have a suggestion? Using the reciprocals. Yeah, I think that's probably going to work out quickest for us anyway. So cotangent v minus 1. It really doesn't really matter which side we start on. I would probably multiply by a fancy version of 1. I can turn this into a 1 by just multiplying it by its reciprocal function, which is tangent, right? So I'm going to multiply by tangent over tangent. I did not see this coming, but it's totally going to work. I'll write out one more step. So that would be cotangent tangent minus tangent over cotangent tangent plus, oh, this was a plus here. I copied it down, plus tangent. And cotangent times tangent is 1. So these both turn into 1s and we're there. I like that problem. So we were talking about the test. I'd say this is getting into, this would be the upper bound of like difficulty level for a problem on a test. You're going to find when we do get around to taking the test, the problems that are going to be on the test are going to be at the lower end of difficulty for these proofs that you're doing. Okay. I want to push you and stretch you on this homework, and I want you to do the very best that you can on it, right? Knowing you're going to get stuck. But when I test you over it, it's going to be at a lower level. Also on the test, you're going to have 2 options for each of your proofs. So you're going to get, if you get stuck on one, you can do the other, and just tell me which one you want me to grade. Yeah. So at this point, don't even be worrying about what's on the test. Test is going to be after Thanksgiving break, after spring break, and so right now, just try and as much as you can, just try and get more confident with these. And the only way you're going to get confident is to do that productive struggle thing. We'll be all right. What else? I got time for 1 or 2 more. Any others that you're dying to see, or at least a hint to get started? 27. 27. Let's talk through strategy. I want to give you the opportunity to finish this one. Is that better? Huh. Interesting. So I see this one. I'm eyeing the left-hand side. I think I would definitely start on the left-hand side. I see this secant plus 1 on the bottom. I'm thinking about maybe multiplying by a fancy version of 1 that's like secant minus 1 over secant minus 1. If I did that, I would get a secant squared minus 1 on the bottom, and secant squared minus 1 is tangent squared. And I think that's going to move me along towards, I think that's going to move me towards this. That's one path. So one way I could go with this, and I'm not going to write out the formal proof for it, but tangent squared x over secant x plus 1. It's when I see something like plus 1 in the bottom, I'm thinking like, can I multiply by that? Like, this is the a plus b. Let's multiply by the a minus b and use that algebraic identity to make our lives easier. That's going to turn the denominator into secant squared x minus 1, which is going to turn into tangent squared. But I'm also seeing another way to do this that I think would actually be easier, which is leave the secant x plus 1 alone on the bottom and turn tangent squared x. That we could use a Pythagorean identity on that, couldn't we? Look on your sheet. What's tangent squared x equal to? It's equal to secant squared x minus 1, isn't it? Now, last year we went round and round. I had some students who wanted to cancel some of these secants. Can you do that? Because of the pluses and minuses? No. What can you do with secant squared x minus 1, though? You can factor that, can't you? That's a difference of squares. What would you get if you factored it? So you would get secant x plus 1, secant x minus 1. Oh my gosh, one of those factors is going to cancel the whole denominator out, isn't it? So you would get secant x plus 1, secant x minus 1. And these would cancel. And now you just got secant x plus 1. And then it's a matter of fiddling around with that to make it look like this. I would probably let me double check here. Oh, it was a plus 1. Oh, I copied it wrong. Yep, copy error. Sorry, that cancels. So sorry. So we end up with secant x minus 1 after all that, right? Does that look better? Thank you for catching that. And then from there, I'd probably turn this into 1 over cosine, get a common denominator, and I think that would get us there pretty quickly too. So there's a couple ways. I don't know how I would do it if I started over here. That would get pretty messy. All right, if you've got more questions, get my attention. I'll give you some hints. We went over a few other problems and I recorded them yesterday. Those are on the YouTube channel. You can find the links on Canvas. And then today, again, I'm going to come around and check off homework. I think I have not yet checked 5.2 for you guys yet. So I want to see that for everybody. But if you happen to have law of sines 1 or 2 done, I'll check them off today. If you don't have them today, that's fine. You still get full credit for them on Tuesday. Okay. Last 5 minutes of class, we're going to do our memorization quiz. So I'm going to set an alarm on my phone to go off.